Hi everyone, welcome back to the Linux. Today we are going to see about Ensemble learning. It is a supervised machine learning technique used for both classification and regression tasks. In the previous videos, we will see some algorithms and dry runs. In the each videos, we will see one algorithms. We will use only one model to train the models, and we will use only one model to predict the output. But in the Ensemble learning, it's a technique that will works on n number of models. Due to the n number of models, the outcome will be, it will majority, like both in the regression and in regression it's like a average of the n number of models. In the classification it will takes the majority votes of the all the models. It's like in the previous models we got an entire data sets, and we use only one single model, only one model, and we will train this data with this model, and upon arriving on new data it will give the predictions, right? It's like, for example, e, what it will do was, it will find the average between the two data points, right? For example, these two data points or average, the line will be looks like average between two these two data points, right? It's like average between two, these two data points. If some data points are like this, in this case it will find some average. This is how the model will train, like it's like assumption. It will, what the model do was, during the training process it will find the prediction. If the prediction is wrong, it will adjust its lines, right? In the linear or logistic regression it will find some lines. Based on the average it will update it weights, right? That's how it will work. Due to the single model, it will only adjust in a single line, right? There is only one model. Due to in a one model it will adjust only one line. However, if there are more number of points, it will find some average between them and will update its length like this. This is how it will update the right. What if these data points are wrong, or we can call as outlier? The outliers are far away from the patterns or noise data like that. What if these data points are an outlier, and these outliers are in a noise can, like, can alter this line, right? It's not good, right? So due to this reason, it will raise the ensemble learning technique. What it will do was, let me erase this. Instead of one model, it will create the n number of models. Like this is in a data set, and this is in a n models. It can be any number of models, hundred or thousands. For simplicity, we can take the three models. What it will do was, we will train the data separately. For example, some data points or entire data sets are given to in a model one. Similarly, for in a model two. Similarly, for in a model three. Let's take dataset 1, dataset 2, or dataset 3, like D1, D2, D3 belongs to capsule D. These are the datasets. We will use this dataset to train all the models. We will select the subset in that dataset. We will train the model like this. It's an I will give it some dry run. For example, each model will train based on this data, right? In previous, like as I told, it will find some average and update its line, right? What if the data or noises or like outliers? It will affect the line, right? So in this technique, we will what we will do was, we will create a subset, right, from the data set. So how, in some cases, if you randomly select these data points on in each different data set, for example, this point goes in the D1, this point goes in the D2, this point go to in the D3. In this case, for example, we consider this point as an like this point as an outliers, right? For this point, it will comes to in a model one. It's like looks like it will only affect some points, right? For similarly, this point to only affect some minimum points, right? For third point, it will create, right? What we will do was we separate the data. We will separate the data because some points may contain outliers that will affect the lines, right? So if you separate the outliers data point to in a all different model, the upon arriving of new data, the model may any one single model can give the wrong prediction, right? Because we you are predicted the like you are splitted the noises, right? We usually split randomly, but in some cases it will split some noises also, right? So due to this splitting, the data points or outliers also splitted, right? So due to that, each model are trained separately, right? Due to this, like the each model can do some mistakes, or we can say each model may do some unique mistakes. So each model do their unique mistake means if this model do some unique mistake as M1, all the remaining models are not done that mistake, right? For example, this model do some mistake M1 and this model will works well in that case, right? This model also works well in that case, right? So due to the ensemble learning, it will find the average or a majority votes, right? Due to that case, it will works well, right? Because only one models do the mistake, right? Other models are works good. So in classification, the majority votes always the true one will win. But in the regressions also, it's like it's find some average, right? It's also like slightly overcome that. So in the previous model, the entire data set given to in a one model, right? It will some cases it will give in a misclassified values, right? So that case will be prevented by ensemble learning because there are a n number of models. The main challenge in the ensemble learning is not it is not to make all the base models too accurate. Let me tell that once again. The ensemble learning, the main challenge is sorry, the main challenge is it's not to make the each model works well. The main challenge in the ensemble learning is we needed to mm, like make the mistakes one mistake by each model. For example, we need to M1 for this model mistake, some other mistake for this model M2, some other mistake for M3. However, if some data points or in a some model it will be misclassified and others are classified correctly, the majority votes the true will wins. Uh, it's like an example. For example, there are in the class there are groups of weak learners. Each will works good on some precise or some specific topic. For example, one who one who loves in physics and do all the problems in physics, and another one will learn well in the maths, and another one will learn in Tamil. Each students or learn each subject as they wish, and each will do on you know on their will subject, right? Based on that, if some problems are comes, the majority will be like some of them or do their mistakes and some of them will works good if there is if the subject is loud that. So in that case the majority will wins. This is how the basic intuition behind the ensemble learning. Why we use the ensemble learning? It's like we need to reduce the overfitting and also in underfitting. What is overfitting? Overfitting also called as variance. What is variance means? In simple example, we can say it as the variance is instead of model, training himself for any data points, it will just memorize the data set. It will works good on training period, and it will works less on the upon the new data. For example, instead of finding this line, it will just memorize all the data points. And during the training process, it will just memorize all the data so that it will works on the stable data like input data. And for a bias, sorry, it works well on the new data, like sorry, it works on the training data well, and it will not works well in the upon new data. Like it will just memorize. For example, if the students only memorize, for example, if the students instead of understanding the complete in maths problem, they will just memorize the steps. So upon receiving the same question in the exam, you will works well, right? Because he just memorized that. But upon receiving the same questions, not in the same questions, they're in a different questions in that method, you will not works well, right? Because he just memorized it, not understand that. This is in a variance. And biases, it's like, they will just find the patterns. It will find the patterns, and it will find the some logic behind the data sets. But for example, let's take an screen. Someone is hitting the arrow in this screen, right? This is a target we need to achieve. We train the model. We train the model like focus on this center point, right? But in the bias, like if it has a higher bias, it will like throw the arrow beyond the target, right? It will like near this or this point or even away the screen. It's like it will find the patterns, and these arrows are like also like these arrows are in a precious near to that point, because each time we throw the arrows, it will looks like this. It's like you focus on the you will throw the arrow on the focused area, but it doesn't know where to focus, like in this is a target. So we will train the model, it will find some patterns, but it will throw the arrows in the wrong direction. It will predict the values in the wrong direction. So that bias is also important. So lesser variance and the lesser bias is preserved. Sorry, lesser variance or lesser bias are used in the machine learning model, and it will improve the accuracy and robustness and stability. There are three types in the Ensemble learning: bagging, boosting, and stacking. Let's see each of them. This is an abbreviation for an bagging. In bagging, what we will do was, I told that this is a technique you, like the Ensemble learning, it's in a technique you. The bagging is in a some method. What it will do was, it will just, it will, let's take in a data set D. And as I told, it has an n number of models, right? For simplicity, we take n equal to 3, that is 3 models. What it will do was, it will sample the data, or you can replace, it will take the subset from the original data set. For example, D1 and D2 or D3. These data sets may contains the duplicates also. It will take entire data set also. It will take the sum data set in the D1. Like if it has an 100 data set in D, D1 will takes also 100, but in this 100, in this 100 doesn't have any duplicate, right? Because it's an original data set. But in this 100, it has some duplicates. Similarly, for an AD2, it taken a 100 dataset, but it has some duplicates. For a third dataset, also 100, but it has a duplicate. It's like, it will pick the uh, same data points that are picked by previously. In each model, or given that sample like D1, D2, D3, and this model usually same models. Most cases we use in a decision tree. These models are trained sequentially. In the given dataset, it will separate the dataset based on the number of models. After that, it will it will train the models parallelly. Sorry, it will train the model parallelly. Once the dataset is splitted, it will given to each model. Each model are trained parallelly, so that each model will trained. After it will train, it will just find some patterns or relationship between the inputs and outputs, and the main challenge is to make the model to make each model some unique mistakes. So overall will be the true one will wins, right? So due to in a splitting of data, it may achieve, right? After training model, upon receiving in a new data like x1, this x1 will be sent to this model, this model, this model. It will give an output, right? It's like for in a classification, it will tell us class 1, class 2, and class 1. Upon this, it is in a classification, right? It is in a classification, right? It will the majority vote is C1, right? It has assumed the it may model 2, it may like it will mistake or misclassified, but two models are says that the data points are class 1, so majority will be class 1. So the given x point will be considered as in a class 1. This is how the bagging will works. This more we can select any algorithms like of an each model, like we taken a decision tree or linear regressions, like that. We taken any models, and all the models are in the same algorithm. For example, model 1, model 2. Model 1 is in a decision tree, and model 2 also must be in a decision tree. If model 1 is in a like logistic regression, and model 2 must be in a logistic regression, and same for in a model 3. It's like all the models use in the same algorithms, and datasets are like taken as a subset. Either it can contains duplicates, and model trains for a classification, it will take as a majority votes. For an regression, it takes as an average. This is how the backing will works. And backing used for an reduce the variance, as I told the variance, right? Variance is it's just memorize the given data, right? Instead of learning some patterns. And bagging is used for an reduce the variance. And let's see for an boosting. In name itself, we can understand boosting. It will boost the data, right? Data sets, right? For example, this is a data set. Similarly, we have a n number of models. For simplicity, we can take an as 3. These are the n number of models, 3 models. And in the backing, we taken a subset, right? But in the boosting, we don't take in a subset, and it will run sequentially, not parallelly. First, what it will do was it will train the model 1 in this dataset. During the training, which data are classified correctly in this boosting, each dataset have some weights. For example, there are thousands of datasets, and each datasets have any weights. For example, N1 has a weight W1, and dataset 2 as a W2, and dataset 3 as a W3, up to a dataset 100. Each model has some weight. If the data points are correctly classified, the weight will be reduced. If the data points are misclassified, the weight will be increased. It's like, it will train the first model. During the training process, if the data points are correctly classified, it just update its weight. So update its weights means it will reduce that weight if it's correctly classified. If the data points are not correctly classified, misclassified, or given some, you know regression value as an wrong, then it will update its weight, or that means it will increase some weight. On the next model, after completing this model training process, it will train this model based on this updated weight, and this model focused on the data points. It will give the more importance or more focus on the data points which has an higher weight. For example, W3 has an higher weight. During this training, during this model training, it will more focus on the data points. These data points, it's like, it will adjust the more parameters for this higher weight, right? Because we need to correct this mistake done by in a previous model. Similarly, it will update it weight also. If it's correctly classified, the weight will be decreases. If it's misclassified, the weight will be increases. Similarly, after training this model, the same data sets with an updated weight by this model are given to this model also. It's like, it will do some mistake, right? First model do some mistake, and it doesn't like corrected by this model. What it will do was, it will just increase that weight, right? Increase that weight and assign to a next model. And this model, it will focus on the misclassified data points by in a previous model. It's like, the first model do some mistake, right? That model doesn't correct that. What it will do is, it will mark as misclassified and increase that weight. So another models can identify that it is misclassified, and giving to an updated weight to an another model, it will find, it will, sorry, it will more focus on that weight, right? So in that model, it will correctly classify the data. It might correctly classify the data, so that this model do some mistakes, and this model will correct that. This model will correct that, right? But in this case, it may do some mistake, like mistake 12, and this model will correct that, right? As I told, the intuition, the main challenge is to make the each model do some unique mistakes, right? This is how it will works. This also here it will works. It's like, this model will do some mistakes and corrected by this model, and this model also do some mistakes and corrected by this model, right? Each model do some mistakes and corrected by a next model, right? This process, or in a, here we can say as number of models 3, we can define predefine that, or we can run this process entirely the datasets which doesn't misclassified fully. We will create many number of models based on the, like, if the model doesn't misclassify. This is how the boosting will works. This will prevent the bias. As I told, it will just focus on a wrong direction, but it will learn something and but focus on wrong direction instead of target. This is how boosting will works. In simple terms, we can say it as each dataset have an weights. If it's correctly classified, the weight will be reduced, and if it is misclassified, the weight will be increased. The next model, it will more focus on higher weight, and it will sequentially executed. Here also, the all the models are in the same algorithms or in the same types. For example, this model used in a linear regression. This model also, this also must use in a linear regression. This also must use in a linear regression. This is how boosting will works, and it's similar to in a bagging. In the case of final outcome, it will just find the majority votes in the classification and take an average for a regression task. let's see stacking. This is a stacked generalization. Stacking stands for stacked generalization. In stacking, usually this model is called as base learner. Base learner. This model is also called as base learner, base learner, base learner. In stacking, what it will do was it will the given data sets. Either we can separately, like you know, we can separate the data set as in a subset, or we can boosting the data sets, or boosting means simply giving with or sorry that the stacking doesn't duplicate the data sets, or also stacking doesn't assign the weight. What it will do is we can create the n number of models, and n number of models are run parallelly. It will give the entire data set to each model. It's not duplicate. It doesn't contain duplicates. It's also not assigned as some weights. The original dataset given to each model, and there is another model. Each model gives some output rights like classified data. Based on these outputs, it will give this output to an input of another model. These models called as base learner, also known as weak learner, and the output of this model given to another model called as meta learn. Based on the outputs of all the base models, or we can say base learners, it will predict the output on some algorithms. It's like in this stacking, each model may have a different algorithm. For example, it can use in a logistic regression. It can use in a SVM, support vector machines, and it can use in a like some algorithms in naive bias algorithm. So in the stacking, we use different algorithms, and we doesn't assign any weights, or in a dataset may contains a duplicate, or we cannot, or we don't split any dataset from the original. We give the entire dataset to each model. You can think like each model works well in the some cases, right? Like SVM works in good at higher dimension data. So logistic regression works well in the linear models, and naive bias works in the classification tasks, right? Each model will works in the some works well in some case, right? So each model will predict some better well for an inputs. So based on that output for an each base model, these output are given to a meta learner. The meta learners also use some algorithms and predict some final outputs based on this output by a base learner, and it will give some final outputs. This is how the stacking will work, and stacking will used for smoothly run the models. Like it will also reduce the variance. It will also reduce the bias. It's like based on the problems or depend on the data set, we use the stacking. These are the three main types in the ensemble learning. Based on the problems and the given data set, we use the different methods. In summary, the ensemble learning is a multiple model working together, and bagging, boosting, stacking are the types. Bagging used for reduce the variance, and boosting used for reduce bias, and stacking used for use all the models smoothly, right? As I told, it will use different models, and it will run parallelly. And that's it from this video. Thank you.